So whenever you have a variable in the exponent, that is considered an exponential equation. In order to solve that kind of equation, we need to take the log of both sides so that we can bring the exponent down. So since 7 to the x equals 12, the property says that means we can add a log to both sides, so log of 7 to the x is going to equal log of 12. So this is still an equivalent equation. We can add log to both sides. The reason we do this is because of the power property. When we have a log, we can bring the exponent down out front, so now our variable is no longer in exponent. So our next step, we make this x times log of 7 equals log of 12. And now our last step, we can easily solve for x by dividing out log of 7 on both sides. So now you just use your calculator and x equals whatever log of 12 divided by log of 7 is. Now in this problem, our variable is still in the exponent, so it is an exponential equation. We'll want to take log of both sides. However, we have to have the exponential term, so the 4 to the x by itself first. We cannot have any adding or subtracting after. We cannot have anything multiplying before. So pretend like this equation just says, let's say 3x minus 1 equals 15. We have to do all the same steps for this as we would for that equation. So first you deal with your addition subtraction. We add 1 to both sides. And we have 3 times 4 to the x equals 16. Now you deal with your multiplication and division. So we divide both sides by 3. 3's cancel. So now we have our 4 to the x by itself equals 16 over 3. Now we can take the log of both sides to bring that exponent down. So again, you cannot take the log of both sides until you have this exponential piece by itself. Now we can do log both sides, and this exponent can come out front because that's the whole point. And we have x times log of 4 equals log of 16 over 3. Now we just divide out our log of 4. So x equals whatever you get when you plug log of 16 over 3 over log of 4 into your calculator. Make sure when you're plugging those logs into your calculator, after that open parenthesis, you close it again so that you don't end up with a double log. For this last one, same idea. Our variables are in the exponent, which means we have to take the log to bring it down. Now this time the extra addition and subtraction is up in the exponent with the variables. So we can't get rid of anything right now. Our two exponential terms are indeed by themselves, so we can take the log of both sides right away. So we have a log of 3 to the 2x minus 1, and we have a log of 0.4 to the x plus 2. So now when we bring this exponent down, the key is we are bringing all of 2x minus 1 down and all of x plus 2 down. And we need to leave those in parentheses because that is, we're multiplying that entire binomial by the log of 3 or by the log of 0.4. So when you bring that down, it should look like 2x minus 1 in parentheses times log of 3. And now we have x plus 2 in parentheses times log of 0.4. So now our goal is to solve for x. So we have our two x terms. They're in parentheses right now, so they're stuck. We cannot move them from side to side. So your next step here is you want to distribute your logs into those parentheses. So we need to get rid of the parentheses by distributing. Remember, log of 3 is just some number. Log of 0.4 is just some number. Some crazy decimal, but if we keep it in log form, it keeps everything exact, which is what we want. So when we distribute that in, we have 2x times log of 3 minus log of 3. We have x times log of 0.4 plus 2 log of 0.4. So now here, this is going to be similar to the inverse equations we were doing earlier. We want to get our x terms to one side of the equation, and we want to get everything without an x in it to the other side of the equation. Oops, to one side get, I guess we can call them non-x terms to the other side. So we do that just by adding and subtracting terms from each side of the equation. So I'm going to get my x's to the left side, which means I want to subtract this minus x log 0.4 from both sides. I want to get my non-x's, so anything without an x in it, to the right side of the equation. So I'm going to add log of 3 to both sides. Now, we can't actually combine anything here because we don't have the same types of logs. So the left side is just going to stay as a 2x log 3 minus x log 0.4. So all we're doing is rearranging. The right side will have 2 log 0.4 plus log of 3. Now, again, similar to the inverse we were doing last week, the left side, both terms have an x in it. We want to get that x out by itself. So we're just going to factor that x out of the whole equation. So we have x times 2 log of 3 minus log of 0.4. Right side still stays the same. Again, remember, all these logs are just fancy numbers. So now to solve for x, we just have to divide by this whole mess of 2 log 3 minus log of 0.4. Divide 2 log 3 minus log of 0.4. So now really the mess at this point is plugging it all into your calculator. So you want to do the 2 log 0.4 plus log 3. Make sure that is in parentheses if you plug this all in at the same time. And then your division sign and do 2 log 3 minus log 0.4. Again, make sure that is all in parentheses when you plug it in. Whatever that equals is your solution for x. And after plugging it all in, so that you can make sure you plugged it in right, you should be getting negative 0.2357.